Okay, so last time we did a first order differential equation using Laplace transforms. Now let's go ahead and do a second order differential equation using Laplace transforms. Let's do, we're doing blue today, I guess. Y double prime minus 2y prime plus y equals e to the t. Okay, let's remember what our keys are. Our keys said that our double prime is going, so the first part is to change everything into, is to take the Laplace transform of the entire thing. Our keys tell us that our first one is s squared times ys minus s times one of my initial conditions. Oh, I need my initial conditions, don't I? And my initial condition there. Let's see what our initial conditions are. Initial conditions are y is 0 and y prime of 0 is 5. Okay, so then my second term, 2 times the Laplace transform of the derivative is s times y of s minus my initial condition. And then my original one is just going to be y of s. And when I look at my chart, e to the t is going to be 1 over s minus 1. Okay, let's pull all my y of s's together. No, let's plug in my initial conditions. So let's plug in the initial conditions first. So this becomes minus s times 0 minus 5 minus 2s ys plus 2 times 0 plus ys equals 1 over s. So that goes to 0 and that goes to 0. Now let's pull together my y of s's. So y of s is going to be s squared minus 2s plus 1. What else do I have? That one's done, that one's done, that one's done. So I have a minus 5 there, equals 1 over s minus 1. Let's go ahead and move that 5 over to the other side. Okay, so move the 5 over to the other side, and now when I divide by this, I'm going to divide both of the terms. So divide this by that parenthesis, and on this side, I'll just put that parenthesis in the denominator. So shorthand, sorry. So 5 over s squared minus 2s plus 1, and we've got 1 over s minus 1, s squared plus 2s plus 1. So this right here will factor, and this one too. And so if we go ahead and factor that, then now we've got 5 over s squared minus 1, not squared, back up. This will factor. When you factor, you get s minus 1 squared, and then over here I have 1 over s minus 1 and s minus 1 squared. So now we have squared and s minus 1 cubed. What does our tables tell us about that? So now this one is, look at all the way down to 23. And 23 says that n factorial over s minus a n plus 1 is going to be t to the n and e to the at. Okay, so for us, we're going to have to, in our case, our a is 1. Yeah, our a is 1, and our n is 2. Our n is 2. So if we rewrote this, we would need to have a 2 on top, but we can't just put a 2 on top. So we're going to have to both multiply by 2 and multiply by 1/2 in order to get our a minus 1. So this gets now rewritten. One half 2 s minus 1 to the 2 plus 1, however you want to do that. So then now when I do my inverse here of this, I am going to get, well, this one I can look, and because of that squared and there's just a number on top, it looks like we're at number 7. And this one, we've already said we're built it up to be 23. So this one's going to be, our a is 1, so 5 sine of t. And this one's going to be 1/2 t to the n. Our n we said was 2. E, our a we said was 1, e to the at. Again, if you guys have questions, please let me know. So the idea is we get something that's really difficult and we get it into an algebra expression or equation that we can write. And I'm not promising that those algebra equations are going to be easy to solve, but they're going to be better than trying to solve that differential equation. As always, if you guys have questions, please let me know.